Hi, this is Maggie. In this video we're going to talk about transitioning between different states in a game. Those states might correspond to levels or to something else, like a demo, high score screen, or a cutscene. This game is called Top-Down Level.py, and it's a game that can easily run at different levels by making small changes to the code. But it contains no mechanism for transitioning between levels. Here the game is running in level 1. What I would like is for the game to transition to level 2 if the player moves through the level 1 exit. You can use a state transition diagram to model the different states of your game and the actions that will result in movement between states. This is Visio, which is software that we can use to draw a state transition diagram. You can draw these diagrams by hand or with any software you like. A state is drawn in a circle. I have 4 states: start, level 1, level 2, and quit. There's no way in this game for the player to basically lose their turn and return to a demo screen, so they can keep playing until they decide to quit. An enhancement to this game would give the player a way to lose, such as running out of time. Between the circles, or states, in a state transition diagram, we show the actions that cause the transitions between states. From start, which is the state before the game begins, the player starts the game and is immediately dropped into level 1. So between start and level 1, I'll annotate an arrow that says user runs the game. Other obvious arrows are from level 1 to quit and from level 2 to quit. I'll annotate these 2 arrows, press close box. I would like the player to be able to move freely between the levels. In this way, they're more like rooms than levels, except that they will change in difficulty. And since the coins will have likely disappeared from level 1 once the user has moved to level 2, there's little motivation to move backward. But if there were a version of the game with monsters chasing the player character, they might like to duck into an old level. So I'm going to put an arrow from level 1 to level 2. And annotate that moves through 1-2 doorway. And I'll put an arrow from level 2 to level 1. and annotate that the same, moves through 1-2 doorway. So this state transition diagram presents a plan for us, and we already handle quitting in the event loop. What we need to now design in the code is that we start in level 1, and that the user can move through doorways into other levels, and which levels those are. So I think one obvious way to begin designing the doorway transitions into the game is to introduce 2 new numbers into the terrain map, one for leveling up and one for leveling down. Here's the terrain map for level 1. I'll rename this castlelevels.txt. And we're already using 0, 1, and 2. So I'll put the number 3 here, where I have a hole in the bounding wall that's meant to be a doorway to level 2. And in the level 2 terrain map, I'll put a 4 where the hole is, and call this file castle2levels.txt. So a 3 means move up a level, and a 4 means move down a level. Now we need to make sense of and handle all of that in the program. Okay, I'm going to rename the program top-down level transition.py. And now in background we will need to take 2 more lists. Which are the lists of doorways up a level and the list of doorways down a level, like the bricks list and the gold list. This is a list of codes from the terrain map that have special meaning. Those will look like regular bricks, but we'll need to find a way to check for collisions with those bricks so we can change level in the appropriate direction. Let's start by getting the program to work with these new bricks in the terrain map, but without any new functionality. So I've added the 2 new lists to the init method. Let's pass them in to the initializer from the level class. We can just pass them into the level initializer and then pass them along to the background. Okay. So I'm going to pass in a list of 3 to match the parameter doorways up, because that's the code that means to move up a level. And I'll pass in a list of 4 to match the parameter doorways down, because that's the code that means to move down a level. These are used as indices into the image files list, the list of images that get drawn on the background surface. Both doorways up and doorways down won't have a special look. They'll look just like a regular floor tile. So I'll add 2 new references to the floor tiles in the list I pass in. I also need to change my terrain maps to reflect the new maps with the doorway codes. Okay, we should see nothing new, but the program should still work. It's just that it's now interpreting two new terrain map codes as floor tiles. Okay, and that works fine. Now, if we think about what we want for the doorways, it's basically a brick. We want an invisible sprite that we can check for collisions with. So in background, I'm going to add two more lists, underscore doorways up and underscore doorways down. And we'll make bricks for the doorway codes of 3 and 4. But instead of storing in the bricks list, which the user can't move through, we'll store in doorway lists. So as we go through the terrain map, we'll check for codes that are in the doorways up and doorways down parameter lists, and we'll add a brick to the doorways up and doorways down fields respectively. We'll then add accessors for those lists, just like we have get bricks and get gold, and we'll add similar fields and accessors to the level and get the doorways in the level. In main, we'll turn these into groups so we can check for collisions. Okay, and now that they're groups, we can check for collisions. Now, what do we do if there's a collision? If we store our levels in a list, then we can keep track of the index of the current level and simply change to the next level by incrementing or decrementing that index. Ideally, we'll write a function to change level, but for now, let's put all of the code right here. So first, let's put those levels in a list, and we'll use an index current level to get the background, doors, bricks, and gold. So levels sub current level is the current level object. And main doesn't need to know what level that is if we write the code generally enough. I'm going to copy all of that level changing code, and down where we have the collisions, I'm going to paste it in and then edit out what we don't need. All we need to do is change the level. So if the player collides with a doorway up, we add 1 to the current level. And if they collide with a doorway down, we subtract 1. Now, before I run this, I'm going to increase the student's speed. Because it takes a very long time for me to get from one end of the window to the other. And let's run it. Okay, and that's very fast. Still not fast enough to get a coin, so we really want to change those times. Now, let me go through a door. Oh no, that's not how we want it to look. We want the sprite to emerge at the same doorway, but put in the new location. Now, there are ways that we can handle this. We can actually make a doorway sprite class and have it keep track of the location the player character should move to when it comes through a door. Or we could have the level manage the information. I'm going to handle this a simpler way because this game is quite simple, but this might not work for a more complicated game. I'm going to give the student sprite a through doorway method and send that the screen as a parameter. I'm giving it to the student because the student knows what direction it's moving. If it's moving right, as it is for this doorway, then it should emerge at the same Y, but over on the left side of the screen. If it's moving left, then it should emerge on the right side of the screen, moving up, emerge at the bottom, moving down, emerge at the top. Now, what I'm concerned with is the sprite getting stuck in a doorway. If it moves right and doesn't move far enough, it'll collide with the doorway in the new level and then move down a level, then collide with the doorway in the old level and move up a level and be in a sort of state of doorway purgatory. So we'll need to make sure the sprite moves far enough into the level that it doesn't end up in a permanent state of transitioning back and forth. Now, I start the sprite at 50-50. So I'm going to try an offset of 50, and I'm going to hard code that. This should probably be a function of the tile size, and so this should be programmed in a more general way. For the long term, consider this a short-term solution that we're trying out to see if it works, that I will probably never fix during this video. Now the player can only move in one direction at a time, so we can use an if-elif structure to test for movement in all four directions. In some games the player can't be moving both left and right, obviously, but might be able to move both left and up, for example. Not this game. Okay. And then down where we're handling the collisions with the doors, I'll send the through doorway message to the student. again, we want to write a function to do all of this because it's duplicate code. But I wanted to write the code here so that it wouldn't jump around too much for this video. Ideally, this should be in a function. Okay, let's test this. And that works great. The student appears in the correct location in the new level and can move both back and forward a level. Now, one thing I noticed in my own testing is that I should be checking for division by 0 in the update method of the student sprite. So let me add that in. Another thing I want to check for is that I'm not moving past the end of the list of levels when I move through a doorway. Technically, that shouldn't happen, but it's always possible that the person who creates the level might accidentally put the wrong code in and create a doorway for moving down a level from level 1 or moving up a level from the last level in the game. So here, where we add and subtract a level, we want to bounds check that and make sure we're not indexing past the end of the list. So I'll do that by checking the current level before I ever add to it or subtract from it. Now, here's a problem. If we run the game again, the coins regenerate, and that's because I'm recreating the group of gold when we change level. Now, the way to get around that is to store them as groups in the level and not lists. That way, once they're removed from the group, they're removed from it for good. I've made that change. You can see these methods return a group. So the group belongs to the level and not the program or main function. And for good measure, I've done the same thing with the doorways. And now we can't cheat and get more coins by returning to the level. Okay, so that is how we plan and implement a game in which the user can transition between states, in this case, levels. I recommend that you take top-down level.py and implement the changes that I implemented here so the player can transition between levels. Once you can do that, you're ready to move on.